Hello everyone, my name is Nick Van Weerdenburg and we're going to start the webinar now. We seem to have most of our attendees signed up, so we still had a lot of people signing up, so we waited a couple of minutes. So today's webinar is going to be continuous delivery for modern JavaScript, and it's going to be based upon our experience at Rangle in continuous delivery with JavaScript solutions, as well as my own experience working in lean manufacturing over a significant portion of my career. And so with that, I'm going to launch into the discussion. So a little bit about myself. I have 19 years in the software industry, and I was a very early adopter of Agile and iterative development. I started off using the unified process from Rational, moved to Agile and Scrum. Applied Scrum to marketing as well as software and different business processes. And I also worked 3 years in Lean Six Sigma manufacturing environments. One in a plant, actually working in the plant, and the other working for a software company that sold Lean Six Sigma software. And I'm the founder and CEO of Rangle.io, and we're a full stack JavaScript company focused on browser-centric single-page apps and this next generation web architecture that's being built on top of JavaScript solutions. If you have any questions while we're going through the presentation, you can ask questions through the GoToMeeting webinar solution, and we will revisit that at the end of the presentation. I'll go look through the questions and answer any questions that have been asked. So with that, talked a little bit about Rangle. We've worked on dozens of different client projects, all in JavaScript. We have a team of 25 developers and designers, and we're one of the leaders in HTML5 and JavaScript solutions. The reason I bring that up is that a lot of our sort of best practices and our knowledge has been refined over working on lots of different projects, and what hasn't worked on one project, we get to try again and use it on another project. So we have a lot of cross-pollination of ideas, and then we've worked with a lot of awesome clients who have also helped us learn and appreciate what their business needs are and their business models. So we work with JavaScript. AngularJS is our primary focus. Node when we're doing a full stack solution, and we do a lot of mobile with Ionic and PhoneGap. And we're very test driven, which is a precursor to lean and continuous delivery, and user focused, which really is part of being test driven and focusing on continuous delivery, which we will sort of get into. So first off, let's talk about what is continuous delivery. And then we'll talk about a continuous delivery maturity model, which is essential for actually getting into a continuous delivery process. And then we'll talk a little bit about continuous delivery processes and tools. So continuous delivery is a philosophy and a process, and ultimately it's a deployment pipeline that reaches from the developer's machine to the production server. And so companies that do continuous delivery and they do that aggressively can push upwards of 200 changes live to their production server on a daily basis. So some companies that were very famous in pioneering continuous delivery were Etsy, Flickr, and GitHub. And there's a lot of things that sort of come together in determining exactly how aggressive you can be. One is your user community, the expectation of the user community, and what the value is in getting updates into production, and then what's the cost of an issue. One of the things about GitHub is that they were built upon Git, so even if GitHub went down for 10 minutes or 30 minutes, they weren't doing continuous delivery on Git. And since that's an extremely complex piece of code, failure results in data loss, so you won't see continuous delivery happening on databases and on Git source control systems generally. But for anything else where you can back out of your delivery, if you have a good back out strategy and a way to mitigate any of the risk, then it becomes a very viable approach. So it's the deployment pipeline, and it's also a value stream and quality strategy that allows frequent continuous delivery of features through that pipeline. And this is why you'll hear about continuous delivery, and you'll hear about Agile, and you hear about Lean. And what Lean is about is really looking to optimize the flow of materials through a plant and continuously improve each step of the process, automate as much as possible to avoid errors, and focus on error removal in the sort of the organization. And that's where a maturity model comes into play, that you won't be ready to do continuous delivery until you've gotten to an error rate and a automation sort of process where you can have that confidence to push your code into production and to pull it back. famously, the Japanese in their car manufacturing plants in the early 70s, when an American went to visit their plant and they saw there was no repair fields, he said, "Where are your repair fields for the cars that aren't turning out right?" And they said, "We don't have one." And he goes, "Well, what do you do if there's an error?" "Well, we stop the line." And that caused the executive to almost have a heart attack, because stopping an automobile manufacturing line, it costs you hundreds of thousands of dollars an hour. But that commitment to quality means that you rarely had to stop the line. And when you did stop the line, there might have been an impact of a few $100,000 of costs there. But because of that continuous improvement from a quality perspective, you're going to have less defects down the road in terms of recall. And so there's a holistic view there of what the value is. And even if you do occasionally have an issue, the learning and the commitment to the continuous delivery process ultimately means that you'll end up with a more robust system. Lean manufacturing as a process focuses on minimizing inventory, work in progress, and waste via continuous improvement of the entire value stream system. And we see this a lot now in Agile, where people talk either about Scrum or Kanban, and Kanban's focused on minimizing the work in progress, having a pull method for bringing new stuff into work in progress, and focusing on minimizing any sort of process impediments to that flow of work. There's actually a pretty cool DevOps novel called The Phoenix Project. I read this last year sometime, and some of it's, I guess, set up in a way that doesn't make it doesn't feel like it's a real world situation, but it does a pretty good job of showing how this one person who's struggling to deliver software in his company slowly learns about lean manufacturing and it adopts it. And there's a few things in there that actually were pretty interesting and eye-opening for me. And one was this discussion about a quality control engineer. And in most companies, you'll hire quality assurance based upon how much quality work you need to do. But from a lean manufacturing point of view, the key thing is not how much work needs to be done in quality assurance, but focusing on the actual flow of material through the system. And if you're a software company and you're trying to do Scrum, not even getting to continuous delivery, and you're delivering features during the week and then they're not being tested because you don't have a full-time QA person and there's not enough work for them to spend an hour a day testing what you're delivering and sit around for 7 hours, you're not justifying the hire because of the capacity. But if you look at it from a flow perspective, and the goal of Scrum to have both features that are sort of ready to be implemented, the definition of ready at the front end of your sprint, and then the definition of done at the back end of the sprint, QA is essential to that. And if you were to actually analyze the economic impact and the impact on the flow of code through your system, hiring a QA person, and even if they only have an hour a day of work to do, makes a lot of sense, because that empowers that sort of end-to-end flow of software. So we talked a little bit about the history of continuous delivery, that there's Flickr, GitHub, Etsy, and it's the logical continuation of unit testing, continuous integration, and automation. SaaS benefits greatly from it, often with feature switches, where you can actually build a feature, deploy it into production, turn it on for one customer, work with them to get some feedback, and then either roll it out to some more customers or turn it off. And as we were just talking about, that sort of agility in the flow of features is much important than the capacity of different parts of the process. You want to focus on bottlenecks and reducing those bottlenecks, and QA is often one of those. So key to lean and keys to continuous delivery is to learn to recognize the source of waste, understand the impact of variance, and recognize continuous improvement as necessary, and really as the fundamental sort of thing that you are implementing. And lean, a common technique is value stream mapping, and it's actually amazing to see this applied intelligently to manufacturing facilities, because people had no idea how inefficient they were. They would have 30 people working, and the thing that was actually slowing down the work and causing lack of productivity was the way that work flowed, and where things had to stop, where things would have to be put into temporary sort of inventory, then moved out again, and then the confusion and what goes where, and running out of space. And so most people are familiar now with modern manufacturing, where you have this flow of material into the facility, through the facility, and out the facility with no inventory and extremely limited work in progress, to the point that if there is a a highway that gets blocked near an automotive factory, it's going to shut down within 2 days because they don't have all those parts sitting in a warehouse ready to be put into the line. They're getting daily deliveries off the truck of engines and seats and other components. But the benefit of that is that the entire sort of supply chain gets optimized for the sort of the flow of material through the production process all the way out to the suppliers. And by doing that and focusing on removing waste and looking for constraints and managing the work in progress, you end up with a much faster flow of work through the system and much higher productivity. And so these iterative improvement cycles are based upon rapid feedback loops where, in manufacturing, a key thing was empowering everyone who was working on the floor to be involved with quality. Anybody could stop the line. And there was this constant focus on continuous improvement. And, that became where you got to this point where you actually had a continuous delivery process for automobiles where all the materials were just always in motion. There was a continuous pipeline from every supplier going onto the truck, going into the car plant, getting built, coming out the door, getting shipped off to be delivered to a dealership. Very similar. I won't talk a lot about this, but it's just sort of an interesting comparison. So in lean manufacturing, there's the 4 M's or 4+1 M's of manufacturing. There's a different set of Japanese words, I think, that mostly started with an S sound, but method, manpower, machine, materials, and then measurement is an optional one. And this is how everything comes together to really empower lean manufacturing. So how you build things, so your software development life cycle, who's actually doing the building. So that's experience, training, the responsibility. So letting anyone stop the line, having the right amount of training, having people trained with the essential quality tools that are important. The actual machinery, so having the right machinery that people don't have to walk around, they don't have to move, they don't have to shuffle things, really designing for the flow, and so the right tools that come into play there. And there's been a tremendous improvement in web development over the last few years with all these great front-end tools that have been developed for Bower and Grunt and Gulp and these things that really allow you to automate the front end experience, and you can tie those into other tools for managing your servers like Ansible and Puppet and Chef and Salt, and even some simpler sort of tools like Capistrano and Fabric that allow you to really create a complete environment where everybody has the tools they need. Vagrant's a great tool for bringing up environments. So you can pull down a project and have it up and running on a developer's desktop in under 10 minutes, and they can actually be pushing code through, for code review and ultimate delivery to production, 10 minutes later. It's amazing what you can do now, and all the tools are there. The materials you use are your specifications, your tasks, your features, your tests. That becomes another part of the process, and then the measurement. Like, are you improving? What's your level of errors, and what needs to be done next from a continuous improvement perspective? A huge thing in lean manufacturing is different types of waste. And one of the things about pair programming is that you're actually putting 2 people onto one computer, but it does create an incredible increase sense of focus. It does a lot of early QA, so the rework downstream sort of gets reduced. There's 2 people thinking about it, so the design gets done better. And one of the key things with software development is the cost change curve. So the further you go in the software lifecycle, the more expensive it gets to make changes. And so anything that really optimizes the elimination of risk up front is great. The downside is that it's too hard to totally eliminate risk, and so you have to also embrace change, as with Agile, and you're finding the right combination of techniques, you get the best of both worlds. And so that's really about eliminating rework, eliminating manual work. So people don't have to spend a day setting up their development environment. When they need to do a build, they don't have to go ask Bob to come over and help them do the build. Everything is automated. Everyone can set up. You need your own sort of test server on AWS that can be automated. If it's not automated, then you have something to test. Maybe you don't bother doing it. You push, you commit your code, and then something breaks because you didn't actually run the test because you didn't have an environment available, and that happens all the time. The actual need to provision environments to help with testing is an incredibly important step. Slow work, obviously. If you got to go talk to someone every time, you need to get something to work, and interrupted work. So with Scrum, having sprints that don't get interrupted. So this is an obsession in lean manufacturing. And if you're thinking about continuous delivery and all the component aspects of it, having this obsession with waste and elimination of it and automation becomes really the right mindset, I think, for moving forward. The other key thing is feedback. So the feedback loops, are things working? And that's one of the things that gets improved a lot if you have a continuous flow system, because if something's not working, your whole system breaks. And that, in one hand, sounds fragile, but on the other hand, it means that you have all the feedback processes in place. And if you continuously work to improve the automation and improve the flow, then things won't break, and you'll have that feedback there so that when things do start to break, it actually means there's a real problem. And so, fail fast is a common sort of principle of software. That's actually a really good one. And there's a difference between failing fast and fragility, right? If you're hiding issues, that's not being strong or robust. That's hiding issues. And so if you think about the evolution of software over the last 20 years, when I started out, every company I went to was not using source control. And so that was one of the first things I got excited about. And I probably installed source control in 5 or 6 different companies. Then how do you handle requirements and make them traceable and make them meaningful as a unit of work? That's where use cases and later user stories came into play. That allowed you to focus on a unit of value that you delivered, and that's your batch size and your unit of work. Incremental development, delivering a bit and so you can get feedback. That was a massive improvement. Iterative development, so you're learning and you're iterating on a feature based upon what's been done. A lot of people try to do Scrum and Agile development, but they just try to do incremental development. They try to get everything right still the first time, and they don't actually embrace the iterative side of things. So, one thing that I think is important is that iterative sort of process. And that's embracing the fact that you are going to redo a portion of your project. If you're redoing too much of it, then there's a broken sort of step there, and that you can look into that further. Unit testing, so that helps in a lot of different ways. One way, if it's being done right, is it actually makes your development go faster, because you're not sitting there running the entire application all the time. Your tests are running it for you automatically. So it's automation of something that you would have been doing through the browser anyway. And if it's done effectively, it's not that much extra work to write it. It also gives you feedback on whether your code is testable, and if it's modular and if it's cohesive. And that's important for architecture and having a good design that can adapt in the future. So it's a feedback loop there as well. Agile and Scrum is really embracing communication with everybody, end users, lean startup methodology, ship early, get feedback. So again, we're really getting more feedback more often. Pervasive automation, continuous integration. So now we're getting feedback every time we commit that our code is working with other people's code. Then we get into DevOps, and we're giving developers, more connection to the whole process, which means things can move faster, things can be done more frequently, and you get more feedback. And that brings us to continuous delivery and continuous deployment, where we're really shortening. We're down to hours. So things that people wouldn't get feedback for 6 to 18 months, which was typical from a software development lifecycle perspective, there's now feedback in an hour or 2 hours. It's a remarkable change, but it's impossible to do without having everything that came before and building up that capability, doing continuous improvement. What was the method, the man, the machine, the materials, and the measurement. That sort of core to building a process where you can do continuous delivery. It's not that, hey, we're going to just start pushing everything live to our website tomorrow. It's not going to work unless you have the confidence in your code that's based upon that feedback loop that goes all the way back through, all these different tools and processes. And so how do you generate feedback? Well, the way we do that is we deliver software more frequently, and we do that using feature-based, incremental, and iterative development. We do more testing of software and running of software. We do that through automated unit and integration tests. Planning meetings. So it's sort of funny in the sense that meetings are considered to be awful, horrible waste of time. But if you do them more often and they're within a context of a meaningful flow of work, then they can be done frequently, and they really help just take a validated learning approach and look for what the issues are. And that's a key thing with Scrum, is trying to make the meetings very focused, removing obstacles. And so you have more meetings, you do them more frequently, but you do them closer to the actual unit of work. And so they're much more meaningful. There's not as much, conjecture and philosophizing. It becomes a lot more practical. Building your environment, so automation to ensure the same environment is used everywhere, and then basically increasing clarity to enable feedback. So to me, this is actually probably the most important thing, and this is what I harp on more and more as I sort of get more experience working with different teams, is that the size of your commit, how you define your feature and how you deliver features really anchors the whole process. And that's actually very similar to lean manufacturing, again, where batch size and the Kanban sort of pull process becomes essential. As soon as you have 10 commits to look at, like 10 features, and those 10 features can't be isolated from each other, you can't do code reviews, you can't necessarily test the code effectively, you can't back out if there's a failure. That's huge. And so getting the right feature size, small commits, and having those go through the system increases the clarity of what everyone's working with, and that enables both more automation, so it's not as expensive to work on a small batch size, because that's where the value stream mapping comes into place. And then it also enables that feedback. Now, if you try to do lots of small commits and it's crappy code and it's without testing and it's not really based upon a unit of value and there's no real sense of batch size and there's no supporting processes so people actually look at the small features and they end up going into production, then it's not going to work. But in the context of a continuous delivery pipeline with all of these sort of steps and feedback mechanisms in place, it becomes extremely powerful. And so some of the types of feedback, we talked a little bit about this, the test-driven development, build often and automate, deploy frequently, automate deployments. Any of these things, if they're not automated, then people are going to stop doing them, right? Well, we got to deploy a smoke build every day. That becomes every 2 days, that becomes every 3 days. All of a sudden, nothing's been done in a week or 2 weeks. It's got to be automated, and a continuous integration server is absolutely essential for this. And then documentation is more than documents. It's tests, automation, code, comments, commit messages, installation scripts. One of the great things about automation is that the automation becomes the documentation, and then what you have to write as documentation is a smaller set, and it's more meaningful because you're not writing pages to describe something, right? You have that sort of script file that does the deployment, and you make sure that all your code is documented, and then your documentation becomes really a meta document set to help guide people through what you're doing. So frequency across the life cycle, DevOps automation to enable zero cost activities across the entire value stream. That's what enables those small features that sort of focus on a small batch size to be done effectively and cost effectively. When people compare Japanese manufacturing to American manufacturing in the early 70s, they couldn't understand it because everything was cheaper at scale, right? You do more of something and it's a lot cheaper. If you do batch runs that are thousands upon thousands of parts and you put them in a warehouse, you're doing the economic cost of that, and it's a lot cheaper. But when you look at it across the whole life cycle, and you see what the impact is of the time and the sort of blocks and flow and the communication requirements, and if there's an issue, right, you're not testing these parts to see if they're good. So now all of a sudden, if there's bad parts, it's in such a huge number of parts that you're probably going to reuse them anyway, or you have to rework them. And so the thing that really changes those economics is looking at the big picture, and then also that automation and continuous improvement that allows a lot of these things that are expensive to not be expensive, and that means that you're getting them for close to free for your small features. Fail fast. So if things aren't working, how do you know, right? So if you have a DevOps person who keeps everything working, you don't really know if it's automated. So what if you change your DevOps manager each week to a different developer? That will definitely tell you if your documentation and automation is up to snuff. You fail fast and you test your automation and documentation. Any developer who can commit to master and push to production with code review. So, if you get fully into continuous delivery and you have any developer pushing to master and ultimately to production, then what you've done is you've created a system that is going to validate how well your processes are working. In this case, your training's got to be really good, and the code reviews and having everyone writing the similar kind of code and having the right feature size, having tests, that will make this successful. If you're failing on any of those, this is a great way to find out. You let anyone push to master and production, and all of a sudden your website goes down, that's really failing fast. Now, you may not want to do that because that's not good for business. However, if you have a great way to roll back and go back to your last version, you've reduced the cost of this, and you're highlighting the fact that, hey, we had 5 fails pushing the production last week, and that's not good. How can we improve that? And so now you have this feedback and the ability to continuously improve. So feedback is the enemy of entropy. If you aren't improving, you're getting worse. Entropy destroys software and software processes. Even if you get to an ideal sort of workflow and scenario, if you're not sort of having feedback, it's going to start to degrade. Your daily smoke builds become every other day. Your commits get sloppier. These things take a lot of discipline. And having a end-to-end continuous delivery process gives you feedback, because if that feedback starts to fall, then your system starts to fail. And so pervasive feedback halts entropy. And so even if you've gotten to a great development culture and you're delivering software extremely well, you grow your team by 30%, and all of a sudden everything starts to fall apart because you built that sort of unit, but you don't have the feedback to make sure that it's still functioning. So that's one of the great sort of values of a DevOps focused continuous delivery process. Automation, so increase the frequency of everything you can, right? That's what we're talking about, is frequency, and automate anything that can be automated to allow cheap iterations and faster cycle times. Automation equals knowledge, so we talked about that. It's built-in knowledge capture, and that verifies your process and gives you that inherent protection against entropy. Automation is feedback for missing documentation, fragile deployment targets, differences among environments. So this is all great and it sounds exciting, but how do we get there? Like how it's obviously a long journey. It's pretty daunting, but it can be broken up into multiple stages. And so the way we like to look at it is to have a continuous delivery maturity model. So phase 1, this can be 3 to 6 months. It could be longer. This phase is actually pretty easy, but most teams really don't get past this. And if you have a huge team, this might take longer. You might have to invest a lot more in training and sort of mentoring and putting in some stopgap processes to really ensure that this is working well. But once it's in place, it works pretty smoothly, and it puts you in the place where you're ready to go to the next stage. And so phase 1 means a trusted source control and issue tracking. Thankfully, this is no longer an issue. I haven't run into anybody who's not using source control and issue tracking for quite a long time. Test-driven development. I think that test-driven development is extremely hard to get to on existing code bases, and this may require a lot of refactoring, or you need a very clear understanding that you're going to use test-driven development on new features and understand what that means. And you may have to invest in getting the rest of your code base up to speed, because tests are really about confidence in your code and confidence in making changes to your code. And so if you want to move to continuous delivery and you have 70,000 lines of code or 100,000 lines of code, and well, you're not going to get there, because there's just absolutely no way you can do it, because your code is probably quite entangled. You make a change in one place, there'll be regressions in others, and unit tests are really the core for building a solid code base that you have confidence in. You can try doing end-to-end testing, which is what they use in the Angular world, the term, but really automated testing using automated test tools that will run through regression testing. But you can only cover so many code paths. So if you're not testing at a unit testing level and that level, you're still going to have a hard time. And so this could be a longer period of time. Maybe this works better for new projects or new features. This actually works extremely well with companies that are moving to a single page application, because it's a fresh start. You're building a completely independent application that's going to be running in the browser and running against an API. And so you can run your integration tests against the API, test that separately, and then build your new UI using all of the best practices for TDD, and making sure you have the right feature sizes and the right commit flow, and start building out your DevOps and your continuous delivery process. So there's a lot of thinking to go on here, but generally this phase is a lot easier, especially on new projects. You can put in continuous integration with something like Jenkins. You can automate deployments, but even if you get through all this, you're still really nowhere near continuous deployment, because we're talking about largely techniques here. We haven't really talked about how effective these things have been. You have continuous integration, and your Jenkins server catches on fire. Everyone does it every time someone does a commit, and obviously it's not really doing a lot for you at that point. But it does enable the continuous improvement. And so you get through this phase, you write tests first, you write your deployment script first, which is actually a great way of getting towards automation. Instead of actually saying, oh, we'll automate our deployment, next week, you can take the same approach as test-driven development. Pair programming on the challenging parts can be extremely effective, so allocating that as part of your budget. That can help a lot in transferring knowledge and getting people up to speed. Even just having pair programming, even if it's not like the most brilliant person who's coming into pair program, even having two developers who are sort of, both struggling with this, that conversation and the extra pair of eyes and the questioning and that sort of thinking helps, right? So, one option is if you have a team of 10 developers and you want to move through phase one, maybe you work at it in 5 pairs for a month or so, and then you go back to your normal development process. Increase the frequency of everything, and which means automate everything. So, this is just a sort of a thing that I've tried and it was very effective. And that if you want to adopt TDD in 1 week, refuse to write console log statements or use the debugger. Like if you're using JavaScript, you'll get completely stuck if you don't write tests, since there's no other way to isolate errors. If you're writing tests, you know that your test is broken and you can back out from that one test. And if you're running it all the time, you're catching your errors right away. And you're really driven to write tests because you're not going to start debugging and putting console statements everywhere. So something to try if you want to, or just shift more to relying on tests. Automation in a week, don't type anything in a remote shell. Do everything via Fabric or Capistrano or a shell script library, shell.js. You can even try to build modules, like put your automation code into a project and have something you can reuse across projects. So that takes us to phase 2, and this phase is extremely hard, and this can take up to 2 years depending on your team and your team growth and what you can actually invest in the process. So you may still have to do a lot of refactoring because this is where you start seeing the metrics. So I guess in phase 1, we could call phase 1 easy no matter what, and then say that the difficulty of actually having a testable code base is really about phase 2, because this is where you need to have the confidence in your code. So you start looking at things like, what are the chances of getting a small feature deployed into production safely in less than an hour, right? Most people can't even think of that, anything less than, say, a couple of hours development and then a week of regression testing, and it's difficult. And then they don't even know how things get pushed into production. There's only a few people who can do it, and you have to have a team there to help if anything breaks. It's challenging. Feature-based thinking. And the other thing is, pushing to production frequently, you start finding where all the failure points are and continuously improving, and you stop running into issues. So, one thing that we experienced with one client is that everything was done right, but things still kept failing going into production, and that's because the staging server wasn't exactly the same as the production server in terms of OS versions, and that created, a nightmare. Just the strangest things would pop up as a result. Feature-based thinking, so small logical commits with good commit messages, with good tests, and continuous integration metrics that are trending excellent, right? So if you're doing a whole QA cycle and regression testing, and that person is starting to get extremely bored, and your CI server is always showing green or purple if you don't, if you just use Jenkins out of the box, your CI metrics are trending excellent, that's a really good place to be. So now you're really getting through phase 2. Again, those small logical commits with good commit messages, that's essential to this whole process. The concept of batch size and something that can flow through the pipeline. A comfortable feature flow, so your work in progress is managed via real Scrum or Kanban process. So you really are working that feature size and flowing things through. All features are reviewed or pair programmed. And deployment and staging is semi-automated at this point. You don't have to fully automate it, but there's no reason not to. And your focus is on clarity, sustainability, and velocity, on flow, not capacity, right? You want to make sure you've got the right process. If you have the right process and the right quality in your process, now you can really start to speed things up and start to get where you start seeing those 5 or 10 times productivity gains that really good agile teams get over traditional teams. Phase 2 activities, lots of Git hooks, JS hint, which is code quality tool. Reject any commit that doesn't pass the JS hint lint tool and doesn't have a good headline. So there's some really good sort of commit message hygiene that you can use so that it's easy to look through your repo and easy to understand what's happening. Single commit per pull request, so squashing commits. Some people aren't fans of that because they get really nervous about losing history. But my opinion is that if you're actually doing small features, then there really isn't the need for more than one commit and one message. And if you're worried about losing a lot of history, that means that you've probably built something that's far too big. And then also having multiple commit messages for a feature, it actually makes it a lot harder to understand. And so if the code isn't clear and the commit message doesn't make the code clear, there's a bigger problem. And I've never been able to see people do good code reviews where you have just 17 commits and lots of different features. It becomes very hard to pull out things, ask certain things to be changed. Anyway, that's one view, and then everyone is a Git ninja, and the commits are clear, concise, and independent. And so that's an interesting thing when you're, say, doing a continuous delivery. If your features get bigger, it also means that there's more dependencies. And if you have, say, 5 developers and they're doing 5 pull requests each in a day, and if those commits start to conflict with each other, then you start having to ask people to redo their pull requests. And for people who don't use Git and pull requests, a pull request is basically where you have a piece of code on a branch and you ask for it to be merged. And a commit is a block of code, and squashing a commit is where you have, say, you've worked on code for a day and you've committed it 5 times, and they typically fixed a bug, almost working, yay, it was working, no, I was wrong, it's not working, and then the final message is, hey, it's finally working. Not a very good set of messages. If you squash those commits, what you do is you turn it into one message and you replay all your changes against the latest version of your code base. And so when you do a pull request, it's a one-click merge, and it's extremely clear that this is the set of code that's changed. It's not that big because it's for a specific feature, and that really then streamlines that process. Anytime, that's that concept of work flowing forward. If your work has to flow backwards, then this becomes a disaster, honestly. And so this is where you really, getting into the flow of the process, having pull requests that get looked at quickly and merged quickly, and having that sort of right batch size so that this actually works, and having good communication to make sure people aren't working on the same stuff, obviously. So finally, that brings us to maturity model phase 3. And this is where you're really moving into continuous delivery. And so I think for a lot of organizations, if you're sort of a decent sized team, maybe between, say, 5 and 20 people, and you've got some element of a code base in place, then this is where you're looking to really make that final push. And so based upon your phase 2, you have a feeling what your metrics are. Are you ready for multiple deploys per day? When you do a commit, are most of your commits being accepted? So everybody's on board with what a good commit is, what a good set of tests are for that commit, the documentation. And that's what I call the first commit acceptance rate. And so if that's high, then it means that everybody's on board and the process is running pretty well there. Then from a quality perspective, what's the percent, and also the quality of your commits going into the system, but then also the quality of your code base as a whole to be able to absorb new commits, new features, right? That's about architecture and fragile architectures and regressions. And everybody who's been working in software for a while has worked on projects where every time something's fixed, it seems to break more things than it actually fixed. And so if you get to this point and you have a high first commit acceptance rate and you're adding new features to your code base, how many regressions are occurring? And this really, if you started from scratch and you have a fully tested code base and they're good tests and you've been doing this all the time, so people are always learning and you have that continuous improvement process based upon feedback, then you're getting there, and you'll start seeing that you're getting less and less issues found on staging versus production, to the point where staging feels like it's a formality, right? Why bother with staging? You can actually discuss getting rid of it. Then the other key thing is, what's the impact of a bad feature deployment? And so maybe you don't get rid of staging right away, but you start doing less and less QA and you start moving quicker to production. But you've put in place something where if there's a bad feature and your server goes down, you can back that out and put up your old version, in less than a minute. And so it'll just be a slight hiccup. And if people are used to you being an innovative company and your customers understand how you work, then, and you notify them that, hey, we just had a slight blip and you can fix it quickly, then this isn't going to really have a huge impact on your business model. GitHub's a great example of that. So how fast are your deploys and rollbacks? But you might be in the industry where you just can't have your system go down for whatever reason. I don't think there's actually that many industries like that. And I think ultimately, if you do move to a continuous deployment process, your system may go down, and you're saying, well, it went down because we do continuous deployment. But the truth of the matter is, even if you did all that regression testing, and then you push it to production, you're still going to have your system go down at times, and your overall process is going to be weaker, and your quality is going to be less because you don't have that focus on continuous delivery. And so you probably have your server going down more often with more sort of fundamental issues that are hard to find by following a full regression staging QA state step. And so when you do continuous delivery and you do have that occasional blip, it's a less impactful blip, it's easier to fix, and it happens less frequently because of that focus. So it's not really continuous. Anyway, I think I've sort of got that across. So you got to look at the whole system and what that means from an overall quality level. And so from a phase 3 perspective, the goal is to review performance metrics, clearly define the cost benefit of production failures, increase frequencies of deployment in the context of your production failure risk profile. And if you're truly mature in your team and process, increasing the frequency will reduce production failures. You're now going down the mountain, not up it, so to speak. So that was my last point, that you're actually having a much higher quality code base that's much more robust, and you can handle issues a lot faster in production, and you will have less ultimately. So a lot of this gets into your process stack, and so there's a lot of great tools. So just on the right side there, npm, yo, grunt, bower, git, jenkins. And then in the modern sort of JavaScript stack, because that's the focus of this webinar, Mongo and Express and Angular and Node. Test-driven development is just built throughout all of these tools, and it's pretty straightforward to get into test-driven development. Most of the open source projects, they all use test-driven development. It's just wired right into the culture and into the stack. And so this helps a lot in terms of the automation. And then going a little bit further out into your production and staging environment management, then you can look at tools like Fabric, Capistrano, and other tools. But you can actually do quite a bit with these basic tools with just a few things in addition to it. So Git, Jenkins, Mocha, Karma, your Kanban Scrum process with Pivotal Tracker or Trello, something like that. And then the commitment, not the attitude, not a tool, right? So you really have to be committed to this. If you really understand the philosophy behind it, I actually would recommend people who are new to this to learn a little bit about lean in another environment, like reading one of the great books on lean manufacturing and understanding a lot of the concepts behind it, because that allows you to apply it to software and apply it from really an understanding and a commitment perspective, not from a let's follow the motions, cargo cult continuous delivery, to borrow that term, where you're copying the practices but you're not actually doing the actual process. And that's a story from I think it was from the Pragmatic Programmer possibly, but it was that there was these islands after World War II that sort of built out the exact same sort of structures of the air forces that were in the area, but they made them out of wood, and they didn't actually work, but they were copying the practice, but not the actual details. And that's where the cargo cult programming and cargo cult sort of continuous delivery comes from as a term, because I hear that fairly frequently now. So if you're always wondering. Git, I think, is pretty much essential for continuous delivery or continuous deployment in my mind. It's not at all like Subversion. Git is very different because it's distributed. And that allows certain things that actually become very useful from a process, even if you're not really doing distributed development. You can rebase. And what that means is you can work on a piece of code and you can update what you've done to be against the latest version. And that becomes essential because you're putting out new versions every day, right? And so by the end of a week of development, you're going to be against something that is radically different. There was like 75 commits made and deployed to production. So Git allows you to rebase. And I've met a ton of people who use Git merge only, and they didn't even know there was a rebase because they're used to Subversion. And what rebase allows you to do is you pull master and you rebase your branch against it. You do that every day. And that means that your code always looks like you wrote it against the latest version of the software. And if there's any conflicts, you fix them right there. And you fix them, with the full clarity of what the changes were and what your changes were. And then when you're ready to do a pull request, you can do an interactive rebase, which allows you to squash your commits. And what this allows you to do is have it, again, be against the latest version of master with a very clear description. And again, this is based upon having the right feature size. And then when you do your pull request, the person receiving your pull request can immediately do a diff, a visual diff against the existing latest version of master. It's not against one that was 2 weeks old. And they can read your comments and they can merge it. There's not going to be a conflict because you just rebased against master. Now, there may be sort of like a queuing issue where someone else just did this right before you and theirs gets merged and now there might be a conflict, but generally those are fairly rare. And this makes a huge impact on continuous delivery. So I say, I strongly look at Git and look at the magic of rebasing, because it really was an epiphany for me when I started using Git rebase. So, part of the Git ZEITGEIST is development. You have feature branches. All commits run on a CI server, so that you're doing a commit and it's always running, and you're getting a sense of what the what the issues are in different branches. You have a release branch where you have QA, EDE tests, acceptance tests, and then you have the master branch, which is always ready to deploy. So this is a huge shift for people who've been on Subversion. Most of the pain people have with Git is they sort of assume it too much that it's similar to Subversion. So investing in Git training is probably going to have one of the largest impacts on effectively adopting continuous delivery. And then also, really learning how to do TDD, test-driven development, and getting your team on the same page of what good tests are, because there is a lot of lack of clarity around that and a lot of different opinions. And you want to make sure that your test suites actually enhance the flow of your features and they don't get in the way, because sometimes breaking tests become a huge drag to development if the test suite isn't really built the right way at the right level of abstraction. And if you're doing frequent delivery and frequent continuous integration, then you have that feedback loop there. You know that your tests are starting to get in the way, and if you respond to that earlier and update how you do your tests and structure them, then you can get over that sort of step. And those are some of the key sort of items. In terms of your code base, you have a lot of test debt, I would say. Most code bases are not very testable. And this is one of the challenges with Angular, in that people start using Angular and they're really excited because now they can, I've met, I don't know, might be almost 25% of our clients have existing code and they've just moved to Git and they haven't done test-driven development, but they really want to do it. And they've just moved to Agile, maybe 6 months ago, and now they're going to start doing an Angular project. Well, for the first 6 weeks or 8 weeks, they're learning Angular, and as a result, learning Angular and testing and doing all these things at once can be rather overwhelming. Learning Git. And so what happens is they focus on learning the tool. They get 3 months into their project, and it's like, okay, now we're going to start testing. And they don't realize it, but they've already created a code base that's not testable. And so they start to write tests, and the tests are awful. The tests are highly coupled. Tests break all the time. And without realizing that, they've basically built a test suite that actually hurts them more than helps them. And they may just give up on it and just think it's all a fad. And so having the right code base and the right tests, and if you do that early enough in your process and you have that feedback loop, you'll ensure that you have good tests that don't actually end up becoming fragile. So, watching out for fragile unit testing, and then having a strategy for existing code bases. So what often works, with sort of older code base, your existing software becomes a service. It gets wrapped in a REST API, and you can write tests against that API, integration tests against the API, and then you can build your new features using Angular or another browser-centric framework. And you start from scratch, and you can actually build out your complex UI functionality with a really good test suite that will enable this continuous delivery process. But there's a lot of thinking and strategy to be done if you're working with existing legacy code. How to automate, Bash, Shell, Fabric, Capistrano, Puppet, Chef, automation-driven DevOps, like ADD, but it's probably not the right acronym. Write Fabric scripts first, just like with TDD, and test and documentation are implicitly written first. Testing the front end. This is one of the great things about some of the newer frameworks, in that before we were doing most of our development on the server, and then we were trying to Ajaxify our application, and we're duplicating that functionality. We're writing JavaScript that's doing Ajax calls back to the server to dynamically update parts of the page, but those page parts were initially being generated on the server, and you're actually writing like a shadow application against the original application. It's it's nuts. But the value of web browsers was so great that we did it, and then we just got used to it. But your data and your HTML and your CSS and your JavaScript get all mixed up because you're using the HTML to inject the data. That's the server-side technique. Then you're using the CSS to find the data and work with the JavaScript. That's the client side. And so you're injecting data in HTML and then you're scraping it out, and the CSS is the mediator, and everything gets fragile. You change HTML, your app breaks. You change CSS, your app breaks. You change the data, your app breaks. That's your typical web app. If you move to a browser-centric app and something like Angular, this gets separated out, and you can actually architect your front-end app because data is not being injected into the HTML. It's being done in a more meaningful manner. So this is not the best, well, I was going to put a diagram in here, but the concept is pretty straightforward in that you have layers, and layers are one of the key sort of architectural software engineering practices. If you can have decoupled layers that have clear responsibilities and data flows in one direction, then things can be changed and they're not going to break lots of things. So with your typical Angular app, you have data, and that data is being consumed by your JavaScript and your services layer. And then you're using Angular's view model to bind that data, or to actually bind the model, the scope, the data model into the HTML. And then you're styling it just to style it. And so if you change the data, all you have to do is update the JavaScript, and that's probably good enough. You're not going to have to update the HTML. If you change the HTML, you just have to change the binding back into the JavaScript data model. And you can change the CSS pretty much however you want. And so this is just not really talked about a lot, but this is a massive change in how you build web applications in a sense that you're now building a front-end browser application. These are all pretty good tools, right? HTML is structure, CSS is styling, JavaScript is your business logic. You could invent different systems for doing it, but when it's layered out like this, these tools are actually pretty good. I'm really happy using them. Like HTML is fine, it's nice. CSS is nice. JavaScript's nice. It's just when it all gets tangled up that you sort of start going insane and pulling your hair out. And the most important thing is you can actually, it's hard to break, and you can test this. So, that's part of the change as well. I think web applications and the web tier are eminently testable when you actually have a decent, application architecture. And that's where this talk is about continuous delivery for modern JavaScript applications. So it's worth pointing out how this does impact that. In terms of process books, there's a great book called Continuous Delivery by Jez Humble. He has lots of talks on YouTube as well. The book's from 2010, so it doesn't cover some newer sort of concepts, but it's still a really good book. And then I usually recommend a recent book on Scrum, and it's sort of funny because I can't actually recommend a book on Scrum because I noticed when I go to Amazon, it's almost every single book on Scrum is rated 5 stars. It's the most bizarre thing. You'd figure there would be more lousy Scrum books out there, but I have to conclude that it's actually pretty easy to write a Scrum book. That said, there are some really good books from people who've been doing it for 20 years. So Mike Cohn, and there's a lot of books out there, but there are a lot of really good Scrum books, and it's just, there are just so many of them, and you can't really just look at the ratings. I wish I actually had the name of the more recent one I looked at, but it was, I think, Scrum Essentials, and it's not too big, and it's based upon a lot of practical experience. Kenneth something. I should add that to the talk. But JavaScript books. So if you're building modern JavaScript applications, the key thing is that this is not your father's JavaScript, to borrow from the Oldsmobile commercials. This is JavaScript for building systems. This is system engineering JavaScript. This is JavaScript as a true programming language. These applications are not cut and pasting jQuery snippets from Stack Overflow into a web page that's being generated by server-side code. You need to write good code. It's got to be modular. It's got to be clear. It's got to be readable, maintainable. You want to write code that you can reason about 6 months later when you look at it again, that people who work with your code can reason about it and understand it and change it. And so JavaScript is fundamentally functional oriented, and this is a great book for getting your mind around that. So thinking in terms of functions and function pipelines, that works great with JSON and REST APIs and stops you from trying to re-implement your sort of prior object-oriented experience in JavaScript. Testable JavaScript is another good book, and how do you write code that's testable? testing early is the key thing there, but there's also the techniques that go with it. So I recommend that book. And then maintainable JavaScript is a similar thing. So code that's maintainable is often testable because some of the same principles apply. It's got to be, low coupling, high cohesion, modular, clear, easy to reason about. And so that is the talk. So thank you very much for joining us. And I'm going to flip over to the questions. I'd meant to leave a little bit more time, but I will hop over to the questions and see if there's any questions to answer. And so one of the questions, someone joined a little bit late. Yeah, so we are recording this and we'll put it up on our website and we will email everyone and let you know when that's available. So if you want to watch it again or share it with anyone. And that was our only question, actually. So I tend to ramble on. So hopefully I answered a lot of questions as I was going through. But thanks a lot to everyone for joining. If you have any questions, you can email me at contact@Rangle.io or on Twitter. Or you can contact Rangle on Twitter. And we will send out a email with the recording when it's ready. And I'd be really happy to hear from any of you with any sort of questions or ideas or anything that you have about the talk. So thanks a lot, and I hope you enjoyed it.